Hi, welcome to Chapter 7. In this video, you are going to learn about definition of acid and base according to three different theories, which are Arrhenius, Bronsted-Lowry, and also Lewis theory. Let's start with the Arrhenius theory. According to Arrhenius theory, acid is species or substance that can produce hydrogen ion or H3O plus when dissolved in water. For example, HCl, you can see H plus is produced. If this H plus react with H2O, it will form H3O plus, which generally known as hydronium ion. While base is the substance that will produce hydroxide ion when dissolved in water, the general example of base is NaOH. Basically, Arrhenius theory is the definition that you learn in SPM. Okay, let's do some exercise. Classify the following species into acid and base respectively. So we have a quick way to do it by looking at the chemical formula. So for this H2SO4, we can see the H, so we can know that this is an acid. While KOH, we see the hydroxide ion, we know this is a base. Barium hydroxide also, we can see the hydroxide ion, it is a base. However, NH3 also a base, but we cannot see the hydroxide ion in the formula, means that you need to write down the chemical equation. Let's predict what are the product form when NH3 dissolved in water. Second theory is Bronsted-Lowry theory. According to Bronsted-Lowry, acid is proton donor, so we will note H plus as proton, while base is the proton acceptor. H2O plus NH3 produce NH4 plus and O hydroxide ion. So how we are going to determine? We will pair H2O with the hydroxide ion. When I compare H2O with the OH negative, we notice that H2O lost hydrogen ion to form hydroxide ion. Therefore, H2O is the Bronsted acid. Now look at the second example. Again, we will use HSO4 negative pair with the H2SO4. So from here, I notice that HSO4 negative gain H plus. So HSO4 negative is a Bronsted base. Now look at the exercise again. Which of the underlying species act as Bronsted base? So recall back, Bronsted base means it is proton acceptor. HSO4 negative, I will pair with SO4 2 negative. So we see that this is lost H plus. While CH3COOH, I will pair it with CH3COOH2, at where we can see here is gain H plus. So please tell me which one is the Bronsted base. Yes, you are right. CH3COOH is the Bronsted base. According to Lewis theory, acid is electron pair acceptor. So generally, when we look at the Lewis structure for the Lewis acid, it is showing incomplete octet. The other way, base is electron pair acceptor. So basically, this base always showing lone pair electron. So let's look at this equation. BF3 react with NH3 will produce BF3 NH3. So if we draw the Lewis structure for BF3, we have the idea that BF3 is showing incomplete octet, while NH3 is showing octet, but there is one lone pair electron. So in this case, which is the Lewis acid and which is the Lewis base? Yes, you are right. Lewis acid is BF3, while Lewis base is NH3. As usual, after the example, we are going to do some exercise. Which of the underlying species behave as a Lewis acid? So according to the definition for Lewis acid, it is an electron pair acceptor. So the first one, H+, as we know, there is no electron. Hence, H+ is ready to accept electron pair. So H+ is Lewis acid. While B and H3, we know this NH3 has a lone pair electron. So it is tend to donate the lone pair electron. So this is not Lewis acid. So the third one, C and D, will be your exercise. In this slide, I'm going to share with you how I remember the definition of acid and base according to three different theories. First, Arrhenius, I see the H. So I know in my definition, there will be H+. Bronsted-Lowry, I can see the O. So in my definition, they supposedly have the proton. While Lewis structure, I see the E. So I will relate it with the electron pair. So now let's see how we remember the definition for acid. We know that according to Arrhenius theory, acid is the species which will produce H+ when dissolved in water. Another term for H+ also known as proton. So later, after produce the proton, it will become the proton donor. Since you are doing well, so later they will accept the electron pair. Let's summarize. There are three theories that we can define acid and base. First, Arrhenius theory. Second, Bronsted-Lowry. The third one is Lewis theory. So according to Arrhenius, acid is the species we can produce H+ or H3O+ when dissolved in water. While according to the Bronsted-Lowry, acid is proton donor. So in this case, H3O+ is the proton donor. When we pair the H3O+ with the H2O, we notice that H3O+ already lose H+. Therefore, HSO4 negative will be the proton acceptor. The last one, Lewis theory, say that acid is electron pair acceptor. So in this case, it's BF3. At where we know BF3 has the incomplete octet, so they are ready to accept electron pair. Hence, NH3 will be electron pair donor. So that's all for this video. I hope you can get the idea of the three different theories about acid